Hello and welcome to my science tutorials. In today's video, we want to look at quadratic factorization, how to get the factors of a quadratic equation. So without further delay, let's begin. Now, a quadratic equation is an equation of the form as squared plus bx plus c is equal to 0. So over here, we can see that we have a, b, and c. These are known values. We have them as known values. We have values for them. And then the x term is what we don't know. Now, the difference between a quadratic equation and a linear equation is that a linear equation only has one variable, let's say x, and it's not raised to any specific power. So we can have 2x plus maybe 3 outside bracket, 4 plus 2x is equal to maybe 18. This is a typical linear equation. But for a quadratic equation, it always has the x component, the variable, raised to a power more than 1. So we can have a over here in this instance is raised to the power 2, or we can have, let's say, as cubed plus bs squared plus cx plus d is equal to 0. This is also a quadratic equation. Now, for this particular type of equation, depending on the coefficient of the x term, that determines the number of answers or the root of the equation. In this particular example, because the x term is raised to the power 2, we have 2 answers that will satisfy this equation and they become the root of the equation. Over here, we expect how many answers? We expect 3 answers for x that will satisfy this particular equation. So this is the format that a quadratic equation takes. Now, there are various ways of solving quadratic equation. You can either factorize them, use the quadratic formula, use the method of completing squares. Okay, so in this video, we want to look at factorization, but not just how to factorize. We want to learn how to get the factors before we look at how to solve quadratic equations itself in the next video. So let's start by looking at an example. So we have to factorize xa plus xb plus ya plus yb. So we are only to get the factors over here. So if we look at this expression really well, we realize that we have xa plus xb plus ya plus yb. This is equal to, if we compare the first two terms that we have here, we can see that x is common for them. And then the third and then the last one, we can see that y is common for them. So we can factor these variables out. Now, if we factor s out between the first two expressions over here, if we factor s out, we will have a plus b inside the bracket. Now, plus between this and this, if we factor y out, we will have y outside bracket, then into bracket a plus b. Now, note that we are having a plus b repeating. Now, in this case, the a plus b is what we call the common factors. Okay, it becomes the common factor, so we don't need to write it 2 times. So from here, on the top over here, we write this and this together as one factor, so it becomes x plus y. Then we repeat one of the common factors, that is a plus b. So these two becomes our factors. So this is what we call the factors of this particular equation. These are the factors of this particular equation. Now let's have a real typical example of a quadratic expression and find the factors. So we have x squared plus 7x plus 12. And we have to find the factors of this equation. Now, quadratic equations are often of the form ax squared plus bx plus c. Now, to factor or to find the factors, the first thing we do is that we use the coefficient of the x squared term to multiply the c. So we have a multiplied by c, we get an answer. Now, that answer that we get over here, we look for two numbers that if you multiply them, you get the answer, but if you add or subtract, you get the middle number over here, b. So let's look at that. So the example we have over here is x squared plus 7x plus 12 is this is the expression. So this is equal to, now the first thing we do is the coefficient of x squared term here is 1 multiplied by 12 is 12. So we have 12. You write that somewhere. Now which two numbers will you multiply to get 12? But if you add or subtract them, you get 7. So if you think really well, you realize that 3 and 4 will do that. So if you multiply 3 and 4, you get 12, which is the C term we have over here after we multiplied A and C. But if you add these 3 and 4, you get 7, which is in the middle over here. So this becomes a suitable number. But we have 2 and 5. But if we multiply 2 and 5, even though if we add them, it will give us 7. If we multiply them, it will give us 10, which is not 12. So we will not go for this. This will not be considered as our possible factors. We only go for 3 and 7 because if you multiply them, you get 12. And then if you add them, you get 7. So we are going to use 3 and 4. So how do you write that? You maintain your x squared. Then you write the 7x in the form of 3 and 4. So you do that by writing, you can write 3 or 4 first. Either way, doesn't matter. So I'm going to write, in this example, I'm going to write 4x first. So 4x plus 3x plus 12. Now if you look at this expression and what is on the left hand side, there's no big difference. We have x squared, we have x squared. We have 7x. Here we have 4x plus 3x. And if you add them, you get 7x. Then we have the constant 12, and then we have 12 here. So we have done nothing to the equation. We just rearrange the equation in a much more easier way for it to factorize and get our factors. Alright, so from here, the next thing we do is to factor out the common terms between these first two variables that we have over here. So between x squared and then 4x, x is common. So we factor x out. Then we have x plus 4 in the bracket over here. Then plus between 3x plus 12, 3 and 12, the factor that is common between them is 3. So we factor it out. Then we have into bracket x plus 4. So if we multiply 3 by x to give us 3x, 3 by 4 to give us 12. Now we can see we have x plus 4, which I said is the common factor. So over here, we just maintain one of it. So we write x plus 3, and then x plus 4. So x plus 3, x plus 4 becomes our common factors. And that is the solution after we factorize this equation. Now remember, we are not solving quadratic equations, so we don't want to find the value of x. We just want to find how to come up with the factors. That is what this tutorial is about today. Right, so let's have a look at another example. So we have to factorize. Let's factorize x squared minus 2x minus 24. Alright, so we have this expression. Like I said, the first thing we need to do is to multiply the coefficient of the x squared term over here and the constant term, which is c. So we have the coefficient of the x term here is 1. The coefficient of the constant is 24, negative 24. So 1 multiplied by negative 24 will give us negative 24. Okay. Now, which two numbers can we multiply to get negative 24? But if we add or subtract them, we get negative 2 in the middle over here. Alright, so if you think at it very well, 6 and 4 can do this job for us. Now, 6 multiplied by 4 will give us 24. But if you add 6 and 4, you are not going to get negative 2. So it means one of them has to be negative. So let's negate the 6. Now, negative 6 multiplied by 4 will give us negative 24, which is what we want. And then negative 6 plus 4 will give us negative 2. That is very good. So it means our factors, our potential factors is negative 6 and 4. So we are going to use them. So we still write our x squared. Over here, instead of writing negative 2x, we are going to write negative 6x plus 4x. Then we bring the constant minus 24. Okay, so from here, we can go ahead and factor out x. So if I factor out x here, I'll have x outside, then into bracket x minus 6 plus between 4x and negative 24, 4 is common. So I factor out 4, then I have into bracket x minus 6 over here. So I can see my common factors. So I will now bring x plus this 4, and then x minus 6. So these guys becomes my common factors. Alright, so let's go ahead and look at another example. So we have to factorize the expression x squared minus 20x plus 100. As usual, I use the coefficient of the x squared term, which is 1 over here, to multiply the c, that is 100. So I have positive 100. Now, which two numbers can I multiply to get 100? But if I add or I subtract them, I get negative 20. Right, if you look at it very well, those two numbers are going to be 10, 10. So 10 multiplied by 10 will give me 100. But 10 plus 10 will give me a positive 20, not negative 20. But what if I use negative 10 multiplied by negative 10? Negative 10 multiplied by negative 10 will give me positive 100, which is true. And then negative 10 plus negative 10 will give me negative 20. So it means that negative 10 and negative 10 will do the work for me in this case. So I rewrite the expression as x squared minus 10x minus another 10x plus 100. So this is equal to, from here I can factor out my x. So I bring x outside. I have x minus 10 over here. Then minus over here I have between 10x plus 100, 10 is common, so I factor out 10. Then I write into bracket x minus 10. So negative 10 multiplied by x will give me negative 10x. Negative 10 multiplied by negative 10 will give me a positive 100. So from here, I can now rewrite my expression as x minus 10, which is this x minus this 10. And then I maintain one of the common factors, which is x minus 10. Now, for this particular example, you can see that we have x minus 10 occurring twice. So we can rewrite this as x minus 10 all squared. And this becomes our factors for factorizing this expression. Alright, let's look at one final example. So we have to factorize the expression x squared minus 49. Okay, so we have x squared minus 49. Now, mind you, if you look at this, we said that quadratic equation is of the form ax squared plus bx plus c. Now, if you compare this with this equation that we have over here, you realize that we don't have an x term over here. If that happens, if you have an expression where you don't have an x term, it means the coefficient is 0. So 0 multiplied by x will give you 0, and that is how come it has not been written. So this whole expression can be rewritten as x squared plus 0x minus 49. Okay, so from here, I can now go ahead and do my usual. So the coefficient of x squared term here is 1 again. So I use that 1 to multiply negative 49. I get negative 49. So which two numbers will I multiply to get 49? Negative 49. But if I add or subtract them, I get 0. So it happens that 7 will do the job for us. So if I multiply negative 7 and positive 7, I get negative 49. But if I add them, I get 0. So I'm going to use that. So I have x squared. Then I write minus 7x plus 7x minus 49. So the minus 7x plus 7x will give us the 0 over here. So we've not done anything to the equation. So now that I have it in this form, I can factor out my x. So if I factor x out here, I have x minus 7 here plus between this and this, 7 is common. So I factor out 7, then into bracket x minus 7. So I can have here x and then positive 7, so that becomes x plus 7. Then I have x minus 7 here, so x minus 7 over here as my final expression. So after factorizing this equation, these are the factors that you get as the true root for this particular expression. So thank you so much for watching. This is how we find the factors of a quadratic equation. Now that we know how to find the factors, we will proceed with the next tutorial and we'll look at how to solve quadratic equations themselves, how we use this knowledge that we've obtained here to obtain the factors and go ahead and find the value of x in a particular quadratic equation where we'll be using the method of factorization. So thank you once again for watching, and I'll see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at solving quadratic equation by the method of factorization. So let's begin by looking at an example. So assuming we have x squared minus 40x minus 6000 is equal to 0. How do we go around solving this particular quadratic equation to get the roots of this equation? Alright, so the first thing we do is, normally quadratic equation is of the form ax squared plus bx plus c, where c is the constant. Now for us to rewrite this equation in a much more easier way to factorize, we first of all use the coefficient of the x squared term to multiply the c term. The result that we get, we try to find two numbers that we can either add or subtract to get the middle term over here, which is b. So let's look at that. If we multiply 1 by negative 6000, it's going to give us negative 6000. Now, which two numbers can we add or subtract to get negative 40? But if we multiply them, we get negative 6000. Right, if we look at negative 100 and 60, that will do the job. Negative 100 multiplied by 60 will give us negative 6000, which is what we get after multiplying the coefficient of x squared by negative 6000. And then if we add these two, we are going to get negative 40, which is in the middle, and that is what we want. So we can rewrite this whole equation as x squared minus 100x plus 60x minus 6000 is equal to 0. So if you look at this, we haven't done anything to the top equation. It's just that we've rewritten it in a much more easier way for us to factorize and get the roots of this equation. Alright, so between this term and then this term, we realize that there is x common, so we can factor out x. So if we do that, we have x outside, x minus 100 here. So if we expand this bracket back, we'll get what we have at the top here. Then plus, between this and this, we can say that 60 is common, so we factor out 60 into bracket x minus 100 here will give us the 6000 we have at the top over here. So we can see x minus 100, x minus 100, that becomes our common factor. So we only write one of it. So x plus 60, we are going to write this as 1. So x plus 60 as one of the factors, and then x minus 100 as another factor. So from here, we equate each of these two factors to 0 to get our answer. So we have x plus 60 equals 0, or x minus 100 is equal to 0. So from here, we have x is equal to negative 60, or x is equal to a positive 100 as our answer. Now, this x is equal to 60 and x is equal to 100 are what we are calling the roots of the equation. That is, they are the values of x that satisfy this particular equation. So if we substitute x equals negative 60 back into this equation, we are going to get 0. And if we substitute x equals 100 into this equation, we are still going to get 0 as our answer. Right, so let's proceed to look at another example. Now, this is a particularly interesting example. We are to solve x power 4 minus 13x squared plus 36 is equal to 0. Now, wait. This is not what we signed up for. We are here to solve quadratic equations raised to the power 2. How come we have quadratic equation raised to the power 4? This is going to be difficult. Now, there is an easier way for you to solve this without having to go through any hassle, and that is what we are going to do. So we just need to rewrite this equation in a way that we can have s squared term to be represented by another variable, and then we solve it and get our answer. By that, I mean I can rewrite x power 4 as x squared squared, and that still give me x power 4. Okay, so I've not done anything to the equation. Then I repeat the remaining terms here, plus 36 is equal to 0. So I've not done anything to the equation. I've just rewritten x power 4 as x squared squared. Right now, from here I can say let x squared be equal to y. So it means wherever I see x squared, let me replace that by y. So over here I'm going to have y with a square here at the top minus 13, then this x squared become y plus 36 is equal to 0. Now this is looking like our normal easy quadratic equation that we can factorize. So we go ahead to factorize this and get an answer. So we multiply the coefficient of the y square here, which is 1, by 36. That will still give us 36. Now, which two numbers can we multiply to get 36? But if we add them, we get negative 13. So negative 4 and negative 9. If we multiply these two, we get positive 36, but we add them, we get negative 13. So we are going to write this as y squared minus 4y minus 9y. It doesn't matter whether you write the 9y or the 4y first. It doesn't matter because you're still going to get the same thing. Then plus 36 is equal to 0. So from here, I can go ahead and factor out y over here. So I factor out y. I have y into bracket. Y minus 4 over here. So y multiplied by y will give me y squared. Y multiplied by 4 will give me negative y over here. Alright, so over here I have minus. Between 9 and 36, 9 is common, so I factor out 9, then into bracket, y minus 4 is equal to 0. So I can now write this and this, so I have y minus 9, y minus 4 is equal to 0. Right, so from here, I can proceed to have y minus 9 is equal to 0, or y minus 4 is equal to 0. So let me erase these guys so that they don't confuse us. Okay, so from here it means my y is equal to positive 9, or my y is equal to positive 4. But now remember, we were not asked to find y, we were told to find x. We decided to introduce another variable we are calling y. So we need to bring that condition back. But we said that s squared is equal to y, which means s squared is equal to the 9 over here. So to find x, we take the square root of this. So we remember to introduce your plus or minus, because whether positive or negative, you're still going to get the same answer. So our x is equal to plus or minus 3 over here. So whether it's positive 3 or negative 3, if you square that, you're going to get 9. Alright, so this is our answer for the first option. The second one is, we are still going to write y squared is equal, s squared is equal to y, then s squared is equal to 4. Okay, so from here, we take the root of both sides. So we are going to have s is equal to plus or minus the root of 4. And that will give us s is equal to plus or minus 2. Okay, so it means whether you square positive 2 or you square negative 2, you are going to get 4. So our answer now, the values of x is equal to, so s is either equal to negative 3, negative 2, positive 2, or positive 3. So these are the 4 values that will make this entire equation equal to 0. So you can see that the x term is raised to the power 4, and then we have 4 answers at the end of finding the values of x. So if it were to be s squared term, just s squared, we are expecting 2 answers. If it's s cubed, we are expecting 3 answers. That is how quadratic equation works. If it is x power 4, we are expecting 4 answers for that particular equation. Alright, so let's go ahead and look at another example. So we have to find the real roots for the equation. So find the real roots of the equation x squared minus 2 is equal to 8 on x squared. Alright, so let's go ahead and try to find the root of this particular equation. So we have s squared minus 2 is equal to 8 on s squared. Alright, so from here, the first thing we need to do is to get rid of the denominator over here, because we want to have this in a linear way. rearrange it to get a quadratic equation before we can proceed to solve. So I have s squared as the denominator over here. So if I multiply through by s squared, I can get rid of the s squared over here. So I multiply through by s squared. So if I do that, I'm going to have s squared multiplied by s squared minus 2 multiplied by s squared is equal to 8 on x squared multiplied by s squared. So s squared multiplied by s squared, that will give me x power 4 minus 2x squared is equal to this. We cancel this, so it's equal to 8. So I can rewrite this equation as x power 4 minus 2x squared minus 8 is equal to 0. Now I have this equation in a linear way, in a linear form. I cannot proceed to try and factorize this equation. Now, as usual, you can see over here that we have x power 4, and that is not what we want. This way, it is a little bit complicated to solve it by factorizing, but there's an easier way to do it. That is to rewrite this as x power s squared minus 2s squared, just like we did in the previous example. Then I say let y be equal to x squared. So it means this whole equation becomes y squared minus 2y minus 8 is equal to 0. Now this way I can solve it much more easier without having to do any long division. So I have y squared minus 2y minus 8 is equal to 0. From here, I multiply the coefficient of the y squared term, which is 1 by 8. So it will give me negative 8. Now which two numbers will I multiply to get negative 8? But if I add them, I'll get negative 2. Alright, so if you look at it, 2 and 4 will do that, but one of them has to be negative. So negative 4 and positive 2 will give you negative 8, but if you add them, you get negative 2. So I have here y squared minus 4y plus 2y minus 8 is equal to 0. So I can factor y out here. So I have y outside bracket, then y minus 4. Okay, if I expand this, it will give me what I have at the top here. Plus between 2y and negative 8, 2 is common. So I factor out 2 into bracket, y minus 4 is equal to 0. So I have from here y plus 2, y minus 4 is equal to 0. So I have y plus 2 equals 0, or y minus 4 is equal to 0. So I have y is equal to either negative 2 or y is equal to positive 4 over here. Now, remember, you introduce y, so you need to go back and do the substitution. But you said that s squared is equal to y, so s squared is equal to negative 2. So s will be equal to the root of negative 2. Now, the root of negative 2 will give us complex numbers. So this has no real solution. So we have no real solution for this particular first term. But the second term, s squared is equal to 4. So if we take the root of 4, you're going to have, this is plus or minus the root of 4. X will be equal to plus or minus 2. So for this particular equation, the real roots, instead of having 4 answers, the real roots, that is the real numbers that can make this equation to be equal to 0, is plus or minus 2. This is our answer as we've obtained from this side. Alright, so let's have a look at one final example. Alright, so we are to find the real root of the equation. So find the real roots of this equation. So we have 3x squared minus 5x plus 2 is equal to 0. Now this is very easy. You can try our hands on it by pausing the video, try and solve it, and let's go. Alright, so the first thing I always do, like I said, is to use the coefficient of the s squared term to multiply the constant. So 3 multiplied by 2 will give me positive 6. Now, which two numbers will I multiply to get 6? But if I add or subtract them, I'll get negative 5. Alright, so 3 and 2. Negative 3, negative 2, if you multiply them, you get 6. But if you add them, you get negative 5. So we'll go with that. So you have 3x squared minus 3x minus 2x minus 3x minus 2x will give you minus 5x plus 2 is equal to 0. So from here, I can go ahead and factorize. So over here, 3x is common. So I factor out 3x into bracket x minus 1. Then over here, 2 is common. So I minus 2 into bracket x minus 1 is equal to 0. So negative 2 multiplied by x will give me negative 2x. Negative 2 multiplied by negative 1 will give me positive 2. So I have here 3x minus 2. Then I have x minus 1 is equal to 0. So from here I have 3x minus 2 is equal to 0, or x minus 1 is equal to 0. So from here I have 3x is equal to 2. So I divide both sides by 3 to make my x stand alone. So my x will be equal to 2 on 3. Or from here I move negative 1 to the other side of the equal to sign, it becomes positive 1. So my solution for this particular equation is s is either equal to 2 on 3 or positive 1. This becomes my real roots for this particular equation. So thank you so much for watching. In the next video, we'll be looking at how to factorize complex quadratic equation raised to the power x raised to the power 4, power 6, power 5. We're going to look at them and see how we solve them in a much more easier way rather than using the complex method that is available. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to learn how to factorize quadratic equations with higher powers very easily. So let's begin. Now, it is very easy for you to simplify quadratic equations raised to the power 2. For instance, a typical example like 3x squared minus 5x plus 2 is equal to 0. It is very easy for you to factorize this quadratic equation. But what if we have the x raised to the power 4 or power 5 or power 6? Where we will be expecting, from this case, we are expecting 4 answers for x, here 5 answers, and probably here 6 answers for x. How do you go around solving this type of quadratic equations much more easily without doing any complicated calculations? So that is the essence of today's video. I want to look at how to use some easy method to solve quadratic equations having this x raised to higher powers. So let's solve the following equations. So we have to solve the following equations. So we have x raised to the power 4 minus 5x squared plus 4 is equal to 0. We have x raised to the power 4 minus 10x squared plus 9 equals 0. Then we have we have 9x power 4 minus 13x squared plus 4 equals 0. Then we have our last expression, x power 6 minus 9x cubed plus 8 is equal to 0. Alright, so let's go ahead and tackle these problems to see how we solve them much more easier. Alright, so let's find out the solution for the first example. So in the first instance, we have x power 4 minus 5x squared plus 4 is equal to 0. Now, in this type of equation, what we need to do, we need to use some substitution method. But before we do the substitution method, we need to rewrite the equation in a way that we can get it as the normal quadratic equation having x squared term. So to do that, we rewrite x power 4 as x squared. This will still give us x power 4. Then minus 5x squared plus 4 is equal to 0. Now from here we say let y be equal to x squared. So it means wherever we see x squared, let's put y over there. So this whole equation becomes y. From here we substitute y in place of x squared here, so we have y, then this power 2 here will come here 2, then minus 5, the x squared here becomes y plus 4 is equal to 0. Now this looks like a quadratic equation, or this is a quadratic equation raised to the power 2, so we can easily solve this and get our answer. All right, so let's continue. So from here we can go ahead and factorize to get our answer for y. Now the first thing we do is we take the coefficient of the y squared term here and use it to multiply 4. So 1 multiplied by 4 will give us 4. Now which two numbers can we multiply to get 4? But if we add or subtract, we get negative 5. Now negative 4 and negative 1, if we multiply them we get positive 4, but we add them we get negative 5. So we use them. So we have y squared minus 4y minus y plus 4 is equal to 0. Okay, so from here we can go ahead and factor out our y. So we have y here, then y minus 4 over here. Then between this and this, we have negative 1 common. So we have negative 1 into bracket y minus 4 is equal to 0. So negative 1 multiplied by y will give me negative y. Negative y multiplied by negative 4 will give me positive 4. So I can now write my y minus this one over here. And then I repeat one of the common factors, y minus 4 is equal to 0. So from here, my y is either equal to positive 1 or my y is equal to positive 4. Now remember, you made a statement that let y be equal to x squared. We did not have that given to us in the question. We introduced it ourselves. So it means that our y is not our answer. We need to substitute it back into this equation and get the value for x. So we say that now this becomes x squared is equal to 1 or x squared is equal to 4. So if x squared is equal to 1, to find x, we take the root of 1, so it becomes plus or minus root of 1, or from here we have s is equal to plus or minus the root of 4. Okay, so x is equal to, the root of 1 is still 1, so we have plus or minus 1, or plus or minus the root of 4 is 2, so s is equal to plus or minus 2 over here. So therefore it means that our roots for x are negative 1, negative 2, 1 and 2. So these are the values, or these are the real roots for this particular equation. So when you substitute any of these values into the original equation, you should get 0 as your answer. So this becomes our answer for the first expression, plus or minus 1, plus or minus 2. So based on this first example that we've done, you can go ahead and try your hands on the second example, the third, and then the last example to see the answers you get and compare them with mine after we are done solving. So you can pause the video and go ahead, attempt the second question, the third one, and then the last one using this explanation I just gave earlier. Alright, so let's begin. So let's look at the second example. For the second example, we have x raised to the power 4 minus 10x squared plus 9 is equal to 0. Alright, so just like we did in the first instance, we rewrite x power 4 as x squared minus 10x squared plus 9 is equal to 0. So I can say let x squared be equal to y. So I do the substitution. I have here y squared now, because x squared now is now y. Then minus 10, x squared will now be y, plus 9 is equal to 0. So this becomes my new equation for me to solve. Okay, so the coefficient of my y squared term is 1. 1 multiplied by 9 will give me positive 9. Now which two numbers will I multiply to get 9 but add to get 10? So 1 and 10 will do that job. 1 and 9 will do that job for us. So negative 1, negative 10, negative 1, negative 9. If you multiply them, you get positive 9. But if you add them, you get negative 10. So we do that. So we have y squared minus y minus 9y plus 9 is equal to 0. So from here we can factor out y over here. So we have y into bracket y minus 1 over here. Then we have minus 9 into bracket y minus 1 is equal to 0. So we have our common factors. So we bring this and this together. So we have y minus 9, y minus 1 is equal to 0. So if we equate this guy to the equation, so we have y is equal to positive 9 or y is equal to positive 1. But we said that y is equal to x squared. So it means that y, which is equal to 9, is equal to x squared. Implies that x squared is equal to 9, or y implies that 1 is equal to x squared. So from here we can go ahead and find our x. So our x is now equal to, we take the root of 9, so we add plus or minus the root of 9, or we have x is equal to, take the root of 1 to get rid of the square here, so it becomes plus or minus root of 1. So for the left hand side we have the root of 9 will give us 3, so our answer here will become plus or minus 3, or over here x will be equal to plus or minus 1. So therefore it means that our roots for this equation are plus or minus 1 or plus or minus 3. So that becomes our answer for the second expression. Alright, so let's try and go ahead and solve the third expression. So we have I, or Roman numeral 3, 9x power 4 minus 13x squared plus 4 is equal to 0. So this is just like the first two examples we've done. Very easy, the same way, and we are going to get our answer. So comment down your answer below before we reach the final answer that we have. Alright, so for this equation we still use the same method. So we have 9 into bracket s squared minus 13s squared plus 4 is equal to 0. I've just rewritten x power 4 as x squared. So from here I can say let s squared be equal to y. You can use any variable apart from y. You can use z, you can use k, any variable at all. Alright, so it means that this becomes 9y squared minus 13y plus 4 is equal to 0. Alright, so now we need to factorize this equation. So we use the coefficient of the y squared term, which is 9, to multiply 4. So 9 multiplied by 4 will give me 36. Now which two numbers can I multiply to get 36 but add to get negative 13? So if you look at it, 9 and 4 will do that for us, because negative 9 multiplied by negative 4 will give me positive 36, and if I add negative 9 and then negative 4, I will get negative 13. So we use that. So we have 9y squared minus 9y minus 4y plus 4 is equal to 0. So from here I can factor out 9y. So 9y outside bracket, then I have y minus 1, then over here I have minus 4, y minus 1 is equal to 0. So my expression will not be 9y minus 4, y minus 1 is equal to 0. So from here it means that 9y is equal to 4, or y is equal to 1, and then over here it means y is equal to 4 on 9. Alright, so this becomes the answer that we have for y over here. But we said that x squared is equal to y, so it means in the first instance x squared is equal to 4 on 9, or x squared is equal to 1. This means if we want to get rid of the square term, we bring the square root sign. This cancels this. So our x is now equal to plus or minus root of 4 on 9 will give me 2 on 3. Okay, because this is 2 squared, this is 3 squared, they cancel the root sign, so we have plus or minus 2 on 3, or x is equal to plus or minus 1, because if you take the root over here, this cancel this, root 1 is still 1, so our answer is plus or minus 2 on 3 or plus or minus 1. All right, so let's have a look at the final expression that we have for this particular tutorial. So we have to solve x power 6 minus 9x cubed plus 8 is equal to 0. Now you can see that this is a little bit different from the first 3 examples that we solved. This is raised to the power 6, but the application is still the same, nothing changes. We first of all rewrite this expression as s squared, but this time around raised to the power x cubed raised to the power 2. That is how we rewrite it, s cubed raised to the power 2. So this will still give us 6. Then minus 9s cubed plus 8 is equal to 0. So from here, I can say let y be equal to s cubed. So it means wherever I see s cubed, let me replace it with y. So I have here y squared minus 9y plus 8 is equal to 0. From here, I can go ahead and factorize. So I use the coefficient of the y squared term to multiply the 8, which is the constant. So 1 multiplied by 8 will give me 8. So which two numbers will I multiply to get positive 8 then add to get negative 9? So negative 1, negative 8 will do that. Negative 1 multiplied by negative 8 will give me positive 8. But if I add them, I get negative 9. So I have y squared minus y minus 8y plus 8 is equal to 0. So from here, I can factor out y. So I have y into bracket, y minus 1, then minus 8 into bracket, y minus 1 is equal to 0. So I have my final expression as y minus 8, then y minus 1 is equal to 0. That means y minus 8 is equal to 0, or y minus 1 is equal to 0. So I have y to be equal to either positive 8 or y is equal to positive 1. But again, we said that let y be equal to s cubed. So it means that s cubed is equal to 8 or s cubed is equal to 1. Alright, so if that is the case, we can go ahead and solve this. So if s cubed is equal to this, we can take the cubic root of both sides. So we take the cubic root, this cancels this. So x is equal to the cubic root of 8 will give me 2. So 2 times 2 is 4 times 2 is 8. So the cubic root of 2 is 8. Or then we take the cubic root of 1. Then the cubic root of 1 is still 1. So this is equal to 1. So for this expression, there are only two answers. S is equal to 2 and then s is equal to 1. So these two answers will make this entire equation be equal to 0 if we do a substitution. So let's try that out. So if we place 1 in here, 1 power 6 is still 1, minus, if we place 1 here, it's still 1 multiplied by 9 is still 9. So 1 minus 9 will give us negative 8 plus positive 8 is equal to 0. So we see that it satisfies this equation. And if we substitute 2 as well, we are still going to get 0 as our answer. So thank you so much for watching. This is how we solve quadratic equation raised to higher powers much more easily, just by doing a simple substitution and then getting our answer. So thank you once again for watching, and I will see you in the next video. Bye bye.